In this video we're going to look at a part called the multi-tool arm lever, which is a part we used on our 2012 robot. To give us a better view of what it looks like, I'm just going to go to the isometric view, and you can see that it is made out of a piece of square extruded aluminum tubing. What I'm going to do first is rotate it into place so that the long axis is along the x-axis here. To do that, I'm just going to select this corner here and rotate it 90 degrees, and then select the gnomon and click there and check OK, and then go to fit to screen. The next thing I'm going to do is just look at the size of the piece by analyzing. If I go analyze distance from one to another, it's 12 inches long, and it is 2 inches square. And then I'll just check the thickness here by clicking here and here. We can see that delta y and z are an eighth, so it's an 1/8 inch thick. And so the next thing I'm going to do is go here and go to stock setup and set the y and z to be 2 inches, and then the x to be just a little bit longer than 12. I'll go 12 1/4 and set the origin in the corner and then display. The reason why I made it a little bit longer is typically when you cut the stock, you're going to cut a little bit longer. You're going to square off one face. We'll square off this face here, measure from that when we're machining it, and then when we're machining this end, we'll just cut off this edge as one of the operations. So looking at this piece, you can see that there's some holes. I'm going to analyze the size of these holes, and I'm just going to click there and there to see that the radius is 0.1, and so the diameter is 0.2 or 0.201, and that is the size of a drill bit that we use to use number 10 screws or 3/16 inch rivets, and so we have a drill bit set up for that, and so we're just going to drill those 4 holes instead of contouring them. And then there's a bunch of weight reduction that we'll mill out with a 1/4 inch end mill. So I'm going to go tool path, drill, and then I'm going to select the points. Instead of selecting them individually, I'm just going to use the mask on arc function. So I'm going to click on that, select one arc right there, and then it says select arc, so I'm just going to put a square around the 4, and you can see that it selects a bunch of arcs, but it's only once I hit enter, it's only going to select the ones in the construction plane. And so you can see that there are 4 points defined, and you can see the pattern that's going to take. If you want to use a different pattern, you can go to sorting and choose any pattern you wish. Once I have that, it lets me choose the tool. I'm going to go to select library tool and find our tools in the TRC tooling. I'm going to choose the number 9 drill bit, which is the standard drill bit we use for those rivets and screws. Once I've done that, I'll go to cut parameters just to check that it's on drill. Since it's only an 1/8 inch material, we really don't have to worry about clearing any chips. Next, on the linking parameters, I'm going to set that depth to -0.125, or the thickness of the material. But then I'm going to want to go a little bit deeper to compensate for the tip and a little bit of breakthrough. The tip compensation is set at 58 thousandths of an inch, and I'm going to go an extra 50 thousandths for a breakthrough there. And that part is done, or that operation is done. Next, I'm going to just select these contours here to cut out the weight reduction. So I'm just going to go tool path contour. Here I'm going to go construction plane and area and select these areas here. I was having a difficult time selecting these areas when I imported the step file, so I chose to import the inventor file, and it works very well. I have both of them for download on the video under the comments. So going to the next thing I want to do is, before I close, I want to cut off the end here. So I'm going to go back to chain and just select this edge here. Hopefully that didn't mess it up. It looks like it selected the whole contour, so I need to change that here in a moment. And so what I'm going to do is just go OK, and I'll go back later and fix that. So here we'll go to Tool, select Library Tool. I'm going to choose the 1/4 inch flat end mill. And then on cut parameters, it's already set on the compensation direction is on the left, which is fine. Depth of cuts, we're just cutting 1/8 inch material, so I don't have to worry about that. We'll keep the lead in and lead out as default. I'm going to have a 15 thousandths inch breakthrough. No tabs, and then linking parameters, everything on absolute, and then go to -0.125 for the thickness of the material, and select OK. So everything looks good except the last chain, so I'm going to delete that and just right click and go add chain. I'm going to make sure that we're on 3D instead of construction plane, and then chain, and then just select that edge there. So now that I fixed that, we can look at the contours. You can see that there are no lead-ins and lead-outs because of where it entered. Again, if you wanted to fix that, a couple things you would need to do is probably change the lead-in and lead-out to be a little bit smaller. Okay. And second of all, you would need to go to each individual chain and choose the start point. And if you went to dynamic, you could choose some point in between here, maybe there. And I'll show you, if we regenerate, you can see here we have a small lead in and lead out. We don't have that on any of the others. And if I was worrying about the lead in and lead out, then I would do that for each individual chain. Again, the purpose of the lead in lead out is to ensure that when the bit comes down and dives, it doesn't leave a little nick on the edge that you're contouring. Since this is just weight reduction, there's no real concern about that. So once we have that, we can just go File, Save As, and we can save it as the multi-tool arm lever operation 1 or op 1. And now we can start looking at operation 2. Before we start on operation 2, I'm just going to change the name of this right now, or save it as operation 2. And then we're going to rotate this with the dynamic X form. So I'm going to go X form, dynamic X form. Okay, hit enter, select the corner here, rotate 90 degrees, and select the origin here, and then bring it over there. Hit check mark. Next thing is I should delete. I'm going to delete this this operation, which were the drill, because if I look, there are no holes on this side to be drilled, so I'm just going to delete that. However, instead of deleting this operation, I'm just going to delete the chains. If you just right click and hit D, you can just delete them really quick one at a time. And now we can go add chain. I'm going to go construction plane area again and just choose these very quickly. I think that's about the quickest way. Now I'm going to get off of the construction plane, go to 3D, go to chain, and then just click the edge there to cut the edge of the stock off and cut the part to length, and go OK. And we can take a look at, let me regenerate here, regenerate, and we can take a look at what the bit's going to do. Everything looks good there, and so we can save that and go to the next one. So I'm just going to go save. Okay, now that operation 2 looks good, I'm just going to go File, Save As, and create operation 3 before I do any rotations. And now we can go to X form, dynamic X form, and rotate this again 90 degrees. And so I'm just going to select this corner here, rotate 90 degrees, and then move it to the origin and hit OK. Now I need to delete the geometry from that previous operation. So right click in D quickly deletes all the chains in that previous operation. And I like to do that because I just like to reuse chains that have the same properties, again the same depth of cuts, etc. So once I get all those weight reduction area checked, I can go to 3D and then go back to chain and select that last edge. Go OK. And it should be good there. We can just double check. So regenerate and see what we got. So things look good there. So now what we'll do is drill the holes. So tool path, drill. I'm going to go mask on arc, select the arc, and then I'm going to select all the arcs. And if there's a problem there, you can see that they didn't select right. There's a couple things we could do. So first I'm going to go back to tool paths, drill. You could select them individually. I'm just going to select this one here. Well, actually, again, let me go mask on arc, select this one here, but then go to a front view here and just select all the holes here. And now I can go back to the isometric view. One thing, sometimes when that switches, I want to really make sure that my work coordinate system is set to top. So now I'm going to just go Tool, Tool 16, and go to Linking Parameters. Again, the depth is -1/8, but I'm going to use a tip compensation with a breakthrough amount of 50 thousandths of an inch. And everything looks good, but just to verify, I'm just going to do a back plot of the drilling. And so we'll hit play, and we can speed that up a little bit. Everything looks good there. If you want to change the order, you can, but I'm fine with how the order is set there. And so now I'm just going to save that and go to prepare for operation 4. So I'm going to go File, Save As, operation 4, and then do a transform, rotate using the dynamic transform. Hit enter, select the corner here, do a 90-degree rotation, and then translate it over and hit OK. Then I'm going to since there's no holes here, I'm just going to delete the drill operation and then delete all the chains in the contour and then just add the new chains. And so I can go add construction plane area and select all these areas here. And hit OK. And I can do a back plot here. Now you may wonder if this operation is exactly the same as the operation on the opposite side, and it actually is not, because of how the part is rotated. It was designed such that you could see through the triangles, and so they are they're aligned, so if I get rid of this and look at the front, you could actually see through all of the triangles, which means that the sides are opposite. If the sides were the same, then I would have just repeated operation 2. So now I can save that, and the part is done.